Okay students, in the last class we had studied the conversion of concentrated ore into its oxide. Now the concentrated ore was converted into its oxide by two types of method, that is by calcination, that is in the absence of air when the concentrated ore is heated. Okay, and the another one was roasting, that is in the presence of air when the concentrated ore is heated strongly, then it is said to be roasting. Now after converting the ores into metal oxides, we will study the second part of the reaction, that is conversion of conversion of metal oxide to metal. The metal oxide formed after calcination or roasting is converted into metal by reduction. The process which is involved here is reduction. Okay, reduction means here oxygen is removed from the metal oxide. Okay, so we can say it is the removal of oxygen, and metal oxide is converted into metal. Okay. Now, here the method used for reduction depends upon the nature and the chemical reactivity of the metal that you have to be obtained. Okay. So here different types of reduction methods are used depending upon the reactivity of the metals. For example, we can reduce a metal by simply heating. Metals placed low in the reactivity series are very less reactive. They can be easily obtained from their oxides by simply heating. Now the ore, that is HGS, that is mercuric sulfide. It is also called cinnabar. Okay, when this is heated in the presence of oxygen, that is by roasting, it forms mercuric oxide HgO plus SO2 gas. Okay, now here mercuric oxide which it forms, it decomposes, or by heating it breaks down into Hg plus O2. That is, mercuric oxide breaks into mercury metal and oxygen. So oxygen gas is liberated and the metal is left, that is mercury metal. Metal oxide will decompose into metal and oxygen by simply heating. Okay, it is applicable for the metals having low reactivity. Here further we can say that the mercuric oxide, again it reacts with cinnabar, that is HgS mercuric sulfide, okay, and it again produces mercury and liberates SO2 gas. Okay, so here we can say that the reaction is on. Due to the low reactivity, the metal oxide it easily decomposes into mercury and oxygen. The second way is chemical reduction, that is reduction by using some reducing agent. Okay, the reducing agent can be carbon monoxide, aluminium, hydrogen, etc., depending on how the metal oxide will react with these. Okay, so the metal oxide are converted into metal and there is liberation of carbon monoxide when carbon reacts with the metal oxide. Here we'll take an example. For example, ZNO, it will react with carbon. Here carbon acts as a reducing agent and it will form Zn, that is the metal, and liberate carbon monoxide. Okay, so here we can say this carbon is acting as reducing agent. Okay, similarly the oxides of iron and lead, they are also reduced by carbon, like PbO plus carbon That is when PbO is reacted with carbon, on heating it will form Pb metal and liberate carbon monoxide gas. Okay. So this is Pb metal, that is lead. Call it as lead. This is lead oxide and here carbon reacts with it. Here again carbon is the reducing agent. Okay. Now only one disadvantage of using carbon as reducing agent is that in small traces of carbon are added to the metal as impurity. Okay. So this is a small disadvantage. Otherwise here carbon, that is coke. Okay. The coke is used for reducing. Okay. Now I told that reduction can be by carbon monoxide also. For example, ferric oxide, this will react with carbon monoxide. Okay. And it will form iron and liberate carbon dioxide gas. Okay. Here we see carbon monoxide is acting as a reducing agent. Okay. And the process here involved is reduction. Similarly, some metals they react with aluminium. Some metal oxides they react with aluminium and form metal and liberate the other product, that is aluminium oxide. Manganese oxide will react with aluminium and it will form manganese and that is aluminium oxide. So here we can say aluminium is acting as a reducing agent. Okay, and manganese oxide is being reduced. Similarly, chromium oxide and iron oxide, that is ferric oxide, can also be reduced by aluminium. And reduction of metal oxide with aluminium is known as aluminothermy. Okay, or it is the thermite process. So you can call this process, that is thermite process. It involves reduction of metal oxide with aluminium. Now some metals they are highly reactive, and for those metals we use another method of reduction, that is by electrolysis, or we can say it as electrolytic reduction. That is by passing a electric current, metal oxide is reduced. So here aluminium, it takes 3 electrons from the cathode and it will form aluminium. Cathode is the negative electrode and anode is the positive electrode. Okay, the electrode at where reduction occurs is called cathode. So for electrolysis, just to understand, there are two types of electrodes in it is cathode and anode. Now at cathode there is reduction and at anode there is oxidation. The cathode is the negative terminal, or we can say it as it is the negative electrode, and at anode it is said to be the positive electrode. Basically, you know, a simple diagrammatic representation if you want to show for electrolytic cell, you can show it in this way. This is a cell, there are placed electrodes. This is a general representation of electrolysis I am showing. One of them will be cathode and one of them will be anode. They will be connected by a battery. This is a rough diagram I am drawing. We will study about this electrolysis detail in the purification of metal. This is just for you to see that what is electrolysis basically. Just a rough idea of it. Here this is the positive end and this is the negative end. This is a simple diagram of. Now what happens at cathode, there is reduction. So electron from the molten solution will be accepted by the aluminium oxide. Here the Al3 plus ion, it will get reduced by accepting these electrons and will form aluminium. Now by this method we are obtaining metal of high purity. Here For obtaining aluminium from aluminium oxide, we add cryolite, that is Na3Al(F6). This is added to the molten solution of aluminium oxide, and then there is electrolysis and we obtain the aluminium. Now after reduction of the metal oxide into its metal, we will obtain the metal, but the metal is not very pure. So what we do? We purify the method. So we can say there is purification or refining of metal. This is the last step. This is the fourth step, and this is the refining, purification. As I have said, this purification method involves generally the three steps, that is liquefaction, distillation and electrolytic refining. Now the first method is liquefaction. This method is used for refining the metals having very low melting point. As they will be having low melting point, they will melt easily and then they will be obtained. How? For example, I say in an earth, in a slope, there is, you have like this kind of thing. Here you place the metal and from here it is heated. Secondly, I say that it melts easily. So when it will melt easily, it will start flowing from the slope. Okay. Now here the pure metal can be collected. There will be some impurities. These impurities will be left. Only the pure metal, it will flow down and it will be obtained. You can say that in this way, by simply melting the metal, we can obtain it purely. The metals which have low melting points such as tin, lead, bismuth are refined by this method. The impurities, they do not melt easily and they remain at the top, while the metal is collected at the bottom of the earth. The next method is distillation. This method is used for the purification of volatile metals. Volatile metals means those metals which form vapors easily. They can be obtained by this method. Example for these type of metal is mercury and zinc, etc. Those having very low boiling point. They boil easily and they form their vapors. Now for this, distillation is the method in which the metal, it melts, the liquid metal is taken and in that this metal is heated and then the vapors, they are obtained, they are then passed through a condenser. When they condense, they again change their state and they become liquid and the liquid metal is again collected. Only the process involves the evaporation and condensation. Okay. So here we can say in distillation, pure metal is obtained as the metal will vaporize and it will form vapors, whereas the impurity, it will remain and as it will be non-volatile. Okay. The third method is electrolytic refining. Now this method is most general and widely used methods for the refining of impure metals. Metals such as copper, zinc, tin, nickel, silver, gold, etc. are purified by this method. It is based upon the phenomenon of electrolysis. In this metal in this method, the crude metal is cast into thick rods and are made the anodes, while the thin sheet of pure metal are made as cathode. So for this we will see the diagrammatic view. Now the crude metal is cast into the thick rod. Here anode is the crude metal rod and we say it as the positive electrode, or we can call it as anode. Now the thin sheets of pure metal are made as the anode. Here this sheet is initially very thin. Now an aqueous solution of some salt of the metal is used as electrolyte. As we are considering the refining of copper, so we will see that this crude metal, this is the crude copper, and here this is the pure copper. So the crude copper is the thicker electrode and the thinner one is the pure copper. What is happening here is, on passing electric current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. From here the metal will start dissolving, it will pass into the solution, and the same amount of metal which is passing into the solution will get deposited on the cathode. Okay, so we will see that there is transfer of the crude metal is transferred and into the solution, and from the solution the metal is getting deposited. So the soluble impurities will go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. The impurities which will be settling down will be called as the anode mud. Okay, these are the impurities which are insoluble in the solution. So these impurities, they are called as anode mud because they are obtained from anode by breakdown of the anode, and it is in this way the pure metal from the anode goes into the electrolyte, and the electrolyte, it goes into the cathode. So basically I have said here there is transfer of the metal. Now we will see what are the reaction involved. This is initially before electrolysis the electrodes were in such case. Now after electrolysis what will happen, that we will see some changes. The change that will occur is that the pure one, that is the cathode, will become thicker and the anode, it will become thinner. Now this is becoming thinner and thinner. Here the anode mud is collected and the pure electrode is becoming. This is after electrolysis what is happening. At one point of time all the crude metal will vanish away and will get a thick cathode. Okay. Now we will see the reaction which are involved in this process. At cathode what is happening and at anode what is happening. Okay. Now at anode there is impure copper. This copper is electrolyzed. Electrolyzed means the copper is broken down into Cu2 plus and liberates 2 electrons. These electrons will pass into the solution, okay, and then from the solution the Cu2 plus will get deposited on the cathode. So this is the copper from the impure anode. This is going to be passed into the solution. They are breaking down this copper and the 2 electrons, they are passing into the solution. Now with that the impurities, they also go into the solution. The insoluble impurity that is accumulating down the anode, and that is the anode mud, and the Cu2 plus that is going and depositing on the, this was the reaction which is involved in the cathode. Now at anode what is happening, the Cu2 plus, it is accepting 2 electron and it will form Cu. So these are the reactions involved. Here the copper is pure This is the electrolytic refining of copper. So these are the refining methods used for refining of metals.